Hello everyone, we are going to start with another lecture of performance management, and in this lecture we are going to deal with the concept of linear programming and shadow pricing mainly, right? So this is basically a good question that has been examined in I think 2009 or maybe 2010, but it's a really good question. So let's start with this. The first requirement is calculate the contribution earned from each queues, right? So contribution per unit is basically the first requirement. That is a 2 marks, and then determine the optimal production plan. Determine the optimal production plan for the typical period, assuming that HC seeks to maximize the contribution earned. That means the objective is to maximize the profit. You should use linear programming graph using the graph paper provided, right? Identify the feasible region, number one, and the optimal point, and accurately calculate the maximum contribution that could be earned using whichever equation you need. Now, the important point here is that you have to accurately calculate the maximum contribution. That means you must calculate points very accurately. That means what examiner is actually trying to communicate is, if you have any solution here, you have to use linear simultaneous equation. You cannot do it like this. Like, okay, fine, approx 1,000 units are here, approx 2,000 units are here. You cannot do it like this, right? So let's just start with the question. Let's see what we can have here. What we have here. Hidden company manufactures and sells. Hidden company manufacture and sell pool cues and snooker cues. There are two products: pool cues and snooker cues. The cues use both the same type of good quality wood, which is ash, which can be difficult to source in sufficient quantity. The supply of ash is restricted to 5,400 kilograms per period. The ash costs $40 per kilogram. So the green version, which I have highlighted, is for the raw material, right? The queues are made up by skilled craftsmen, highly skilled labor who are well known for their workmanship. The skilled craftsmen take years to train and difficult to recruit. HC's craftsmen are generally only able to work 12,000 hours in a period. The craftsmen are paid at the rate of $18 per hour, right? Material cost was $40 per kilogram. Labor cost is 18 per hour, right? Now, what's next? The company sell queues in large market, and demand for queues is strong. In any period, up to 15,000 pool queues and 12,000 snooker queues could be sold. That means what? That means examiner is trying to communicate that, look, we cannot sell more than 15,000 pool queues and 12,000 snooker queues, right? The selling price for pool queues is 41, and selling price for snooker queues is 69. Now, what you are supposed to do, manufacturing details for pool cues, snooker cues are given here. So first of all, you have to calculate the contribution, right? In this case, craftsman time period, which is the labor, is given here, ash, which is material, given here, and other variable costs, right? So I'm just allowing you 4 to 5 minutes, 2 to 3 minutes to calculate this contribution, and then continue with this video, right? If you cannot if you are unable to calculate this, let's just see this. See, first of all, we have to assume that let X and Y be the sales volume of snooker cues and pool cues, right? No, pool cues is before snooker cues. Let's make it this way, right? Now, so the first step is to make an objective. And what is the objective? Objective is to maximize the contribution. Oops, sorry. We have to calculate the contribution. Sorry. Let's calculate contribution here. We are doing the first part. Sorry, I forgot it. We are doing the first part, right? So contribution from pool cues and contribution from snooker cues. Right? So contribution from pool cues and snooker cues, right? So we have to start from selling price. Selling price is given here 41 and 69, right? Selling price is 41 and 69. Then direct material is 270 grams of ash, and the price is $40 per kilogram. So 240 times 0.27. I think 270 divided by 1,000. Sorry, 270 divided by 1,000 times 18, I guess. Yeah, 18 or 40? 40. Sorry. 10.8. So material cost is 10.8 for pool cues, and okay, fine. Both product require same input, so that means 10.8 grams. Sorry, $10.8 for direct material for snooker cues as well. Direct labor hour, 0.5 hours and 0.75 hours. So 0.5 times 18 is 9, I guess. Yeah. And 0.75 times 18 is 13.5. Right. Other variable cost is $1.2 for pool cues and $4.7 for snooker cues. Right. So this will be the contribution for pool cues. This will be contribution for snooker cues. Right. So 41 minus 10.8 minus 9 minus 1.2, that makes 20. And 69 minus 10.8 minus 13.5 minus 4.7. It's 40, right? So what will be the contribution function then? Contribution will be contribution, sorry. Our objective is to maximize, right? To maximize contribution, and contribution or profit, both are same. 40 of, 20 of X plus 40 of Y. This is the first equation, right? Now, the second one is to develop constraints, right? And how can we develop constraints here? The first constraint is material, but sorry, the first constraint is labor. No, sorry, the first constraint is material. It's maximum 5,400 kilograms available, right? So what we will write for ash, we will write, you may pause this video and try to develop constraint at your own. 0.27 of X plus 0.27 of Y should be less than equals to 5,400. And for labor, or not labor exactly, here is craftsman, right? It's 0.5 hours in X plus 0.75 hours in Y should be less than equals to 12,000, right? There are two more constraints. The first one is pool cues and the second one is the snooker cues, right? So the demand constraint in this case is X is the pool cue, right? X is the pool cue. So pool cues are restricted to 15,000. So X should be less than equals to 15,000. And snooker cues should be less than equals to 12,000. Right? And then there is a non-negativity constraint. Non-negativity constraint is X and Y should be greater than equals to 0, right? So now we have to develop some points. We have to, for graph, we have to prepare some point, right? This is the graph area, right? Let's start calculating the points for ash. 0.27 of x plus 0.27 of y should be less than equals to 5400. Well, let's equate this, right? So if x is equals to 0, y will be equals to 5400 divided by 0.27, it's 20,000. And when y is equals to 0, x will also be equals to 20,000, right? So this is basically for ash. Now, what is for labor? Labor equation is 0.5 of x. I mean, this you can write, this is for ash, this is for labor, right? 0.7 of x, 0.5 of x plus 0.75 of y should be equals to 12,000. So if you plug in x is equals to 0, y will be equals to 12,000 divided by 0.75. Oh, sorry, 0.75. Yeah, 16,000. And when y is equals to 0, x will be equals to 24,000, I guess. 12,000 divided by 0.5, yeah. Right? And demand function, we usually directly make that. So let's just start preparing that graph. It's really, very important to have a good graph here. So this is the x-axis, right? And this is the y-axis. Right? So we have values till 24,000. So let's make a gap. Let's have a gap of 4,000. I guess it's fine. So 4,000, 8,000, 12,000, 16,000, 20,000, and 24,000, right? 4,000, 8,000. Yeah, it's fine. 4,000, 8,000, 12,000, 16,000, 20,000, and 24,000, right? So this is X and this is Y, right? So first we have to plot. You may pause this video and do it at your own. First we have to plot ash. Ash is 20,000 and 20,000, both sides, right? So it's simple. Right? So this is what, this is material, and material is ash, and its equation is 0.27 of x plus 0.27 of y should be less than equals to 5,400, right? Now what's next? Next one is labor, 16,000, x0, y 16,000, y0, x 24,000, right? So this will be what? This will be, yeah, right? So this is what, this is labor, 0.5 of x plus 0.75 of y should be less than equals to 12,000, right? Now then there is demand function. Demand says that x should be greater than equals to 15,000. So 15,000 means this is 14,000 and this is 15,000. So This will be somewhere here, right? And this is X should be less than equals to 15,000. And then it's less than equals to 12,000. So 12,000 is straight here, right? Right. So this is X, sorry, Y should be less than equals to 12,000, right? So what is a feasible area? Feasible area is simple. Feasible area is the simple line. Feasible area is, since all constraints are less than constraints, so feasible area will be the, or it will be the area which is next to the origin, right? So this area is the feasible area. So I'm just trying to point out its point A. This is the value of B. This is C. This is D. And this is E. See, there are 5 points in the feasible area, right? And this is O, right? So this is basically the feasible area. Now, what now we have to do, see, we have two options, we have two choices. The first choice is to calculate X and Y, values of X and Y at all 5 points, and then plug in into the objective function and then figure out what is the solution, right? But it's not a good idea, because if you do that, it will take a lot of time. So we should try to make ISO contribution line. ISO contribution line is always prepared by using this objective function. So the objective function is 20x plus 40y, right? And we usually keep its multiple, so it's 800. So if you put x is equals to 0, y will be equals to 20. If you will put y is equals to 0, x is equals to, if you put x is equals to 0, y 20, if y is equals to 0, x will be equals to 40, right? But the problem is we cannot plot 20 and 40 here in graph, because graph is in 4,000, 8,000, 12,000. So what we simply do is we'd simply expand this like this. It's simple. It's not illegal. It's simple. So 2,000 on Y, 2,000 on Y means here. And 4,000 on X means here, right? So that means what? That means this is a very small line, but again, it's important line. We try to adjust its slope. Yeah, now it's better. Right, this is the objective function. Let me draw a dotted line here. Right, so this is the objective function, and if you move it away from the origin, I mean, we can put it like this. Right, and this is basically how we move it away from the origin, right? So the point which will cut at last, which will left behind, which will cut at last, or which is farthest, which is farthest from origin, is the ideal solution for us. So we'll move away from the origin. The lowest point, the first point, which is which is cutting through this point, is E. It's the least profitable product point. Then D, then A, then C, and at last it's B, right? So B is the ideal solution. I'm repeating this. We made this line ISO contribution line. We are moving it away from the origin. Its slope is not moving. So the last point which is left here is point B, right? So B is the solution. B is solution, right? Now, what are the points for B? What is the solution at B, right? You need to figure it out. So point B is what? If you want to calculate what are the values at point B, you have to check which points are actually making B. B is made up of Y, a demand function, this line, and this green line, right? Green line is for labor. So labor equation is 0.5 of X plus 0.75 of Y is equals to 12,000. And the second one is 12,000. Y is, I mean, the given amount is less than equals to 5, but we are assuming it's 5, it's 12,000 because we plot this line at 12,000. This line is at 12,000, right? So it's simple in this case. We just need to plug in the value of Y in this above equation and calculate the value of X. You don't have to solve it in that manner as we did in the previous video. So 0.5 of X plus 0.75 of 12,000 is actually equals to 12,000. So 0.5 of X plus 0.75 into 12,000 is 9,000 is equals to 12,000. So let's try to calculate directly the value of X. 12,000 minus 9,000 is 3,000. 3,000 divided by 0.5 is simply 6,000, right? So at point B, X is equals to 6,000 and Y is equals to 12,000. That means we should make 6,000 units of pool cues and 12,000 units of snooker cues, right? So are we done with this question, with this requirement? We made an optimal production plan. We used linear programming. We identified the feasible region. If you want to identify the feasible region as a graph, you may. You may do it, you may shade it, or you may write it that area A, B, C, D, E, O is the feasible area. You can write it. It doesn't matter. And the optimal point accurately, we are done with this, and calculate the maximum contribution that could be earned. So we haven't calculated maximum contribution, right? So how can you calculate the maximum contribution? Maximum contribution will be, remember that ISO contribution line? Sorry, objective function C is equals to 20x plus 40y. So you just need to plug in these value, 20 of 6,000 plus 40 of 12,000. So 20 times 6,000 plus 12,000 times 40, 600,000. So the maximum contribution is $600,000, right? So this is the easier part, right? This is very easy part. So this is 12 marks and 2 marks around. We are done with 14 marks. Now, next part is really very important. It says, some of the craftsmen have offered to work overtime, provided that they are paid double time for the extra hours over the contracted 12,000 hours. So this is the same thing which I said that, look, some people may offer you that they can relax the overtime, the scarce resource, provided that you pay them more, right? So this is something. Etsy has estimated that up to 1,200 hours per period could be gained in this way. Now, what you are supposed to do, you are supposed to explain the meaning of shadow price, right? This is the first thing which you have to do, and calculate the shadow price of both labor, craftsmen, and the material ash. So first you have to do is to explain what is the meaning of shadow price. So you can explain it in your own word that shadow price means the contribution, the extra contribution which company can generate from the availability of one additional unit of binding constraint. It's not a big deal. The important thing is that you have to calculate shadow price of both labor and material. But for that, you really need to identify, if you want to calculate shadow price of anything, you must calculate whether the resource is in binding constraint or not. If the resource is binding constraint, only then you can calculate the shadow price. If the resource is in slack, you cannot calculate its shadow price, right? So see, the best thing which you can do is, if there is a graph and these are the lines, right? And if This is them. These are two further lines, right? If solution is this, if solution is at this point, then any line over and above this point will be in slack. I mean that this line is over this particular line. So this line is actually slack and this line is actually binding constraint. Similarly, if suppose this is not the solution, right? Right, this is not the solution. Oops, sorry, I'm unable to do that. Suppose this is the solution. So if this is the solution, then this line is above the solution. So any line which is above the solution is in slack. And any line which is actually developing the solution is the binding constraint. So in this case, my solution is what? My solution is at point B. At point B, labor is actually a factor which is creating this solution. So labor in this case is the binding constraint. And since ash is over and above this point, then ash can be considered as a slack. But if you can't, if you really want to show this thing, then how can you show this? See, what is the solution? Solution is 6,000x and 12,000y, right? So what we can do is, if you really want to prove which is binding constraint and which is slack, you just need to plug in these values in this equation. So 0.27 of x plus 0.27 of y should be less than equals to 5,400, right? So 0.27 of x in this case is 6,000. And I'm telling you, this is not going to be a binding constraint because this is above the solution. Plus 0.27 of what? 12,000 equals to 54,000. Should be less than equals to 54,000, right? This one. Now, let's calculate this. 0.27 times 6,000 plus 0.27 times 12,000. 4860. We are getting 4860 on the left hand side and the right side is 5,400. That means we are unable to utilize 100% material. So material is not an issue here. Material is in slack. So there will be no shadow price of material, despite of the fact that they are asking you to calculate the shadow price of material as well. You will write that since material is in slack, since material is in slack, therefore the shadow price of material is 0, right? Now what will be the shadow price of labor? See, shadow price of labor is simple. Oh, sorry. First we have to prove that labor is in slack. Labor is a binding constraint, right? You have to calculate for ash and labor. Ash is slack, so we don't need to calculate its shadow price. Let's try to figure out whether labor is a binding constraint or not. I'm telling you that labor is a binding constraint because this is actually developing the solution. But let's try to do this. 0.5 of x plus 0.75 of y should be less than equals to 12,000, right? So we will plug in 0.5 of 6,000 plus 0.75 of what? 12,000 should be less than equals to 12,000. So let's try to calculate. 0.5 into 6,000 is 3,000. 0.75 into 12,000 is 9,000. So this left hand side is equals to 12,000 and which is equals to 12,000. So this resource will be 100% utilized. So we can conclude that labor is a binding constraint, right? So since labor is a binding constraint, we can calculate its shadow price, right? Now, how will we calculate its shadow price? It's simple. We just need to identify those equations which are developing the solution. See, actually what we have to do, we have to identify that if this line, this is the solution now. So if this line moves, if this green line moves somewhere upward or downward, because we are trying to secure one more labor hour, what will be its impact on solution? So its impact of its solution will be created by these two lines. Ash is not involved here. So how we will do this, let's see. For shadow price of labor, right? Shadow price of labor means we have to use labor equation. So 0.5 of x, 0.5 of x plus 0.75 of y should be equals to 12,001. So, right? And the second equation in this case is the demand function, right? Which is an easier one. Y is equals to 12,000 here. So if you really want to equate this, how you can equate this? We will plug in y here. So we can calculate the value of x, 0.5 of x plus 0.75 of 12,000 is equals to 12,001. So what will be the value of x in this case? Let's try to calculate. 12,000 multiplied by 0.75 is 9,000. So 12,001 minus, 12,001 minus 9,000 is 3,001 divided by 0.5 is 6,002. Right? 6,002 units. So that means what? That means there is no change in y, there's just change in x. So what will be the shadow price in this case? There will be no change in x, sorry. There will be increase in 2 units of x. That means what? 2 multiplied by, what is the contribution of x? X contribution is 20, right? So multiply it with 20. Right? And there is no change in y. So the shadow price of labor is, shadow price of labor is 40 per hour. This means what? This means that this is the contribution which HC can generate from availability of one additional labor hour, right? So this is what we mean by the shadow price, right? So we are done with this part. The examiner asks you to calculate the shadow price. So you just need to define the definition of such shadow price, and you have to deny that there will be no shadow price for material because it's a scarce and binding labor is the binding constraint. That's why we are calculating its shadow price. Now this D part. Now D part is also very interesting. I personally believe that D part is the only part in this whole question that may go wrong for any student. Otherwise, overall question is really very easy. Advice, and in fact, in part D, there is just 2 points which can be problematic for any student. Otherwise, it's very easy. Advise HC whether to accept the craftsman's initial offer. What is the initial offer? Initial offer is this one. Some of the craftsmen have offered to work overtime paid for double time, provided that they are paid double time for extra hours over contracted hours of 12,000. Double overtime means if you are paying them $9 per hour, overtime, they will ask you to pay $18. I mean, $9 normal, $9 extra. If you are paying them $10 per hour, then they will ask for $20. If you are paying them $20, they will ask you for $40, right? So that's what you mean by paying the double time. SE has estimated that up to 1200 hours per period could be gained in this way. Now, what you have to do, advise the SC whether to accept the craftsman's initial offer of working overtime, discussing the rate of pay, whether rate of pay is acceptable, requested the quantity of hours, these 12,000 hours, 1200 hours, and one other factor that should be considered. So 6 marks. So 6 marks are here. 3 requirements are here. You have to consider wage rate. You have to consider not wage rate, the requested pay. You have to consider the number of hours, and then any other factor, right? So if they are asking for double rate, then double rate means what? $18 is per hour. So for overtime, they will be asking for 36 rupees, $36, right? So let's try to figure out what is the shadow price of labor. Yeah, we are doing it here. See, shadow price, this is the part. Shadow price of labor is what? Shadow price of labor is $40. That means if they get 1 extra hour, they can generate additional contribution of $40. Now, what they are asking for, they are asking you to pay them double overtime. Double overtime means what is the extra amount? Extra amount is overtime premium. So what is the extra? What extra they are asking? They are asking extra to be $18. Total payment will be 36. But out of 36, 18 is the normal amount. What is the extra amount? Extra amount is the further $18 which they are asking. So that means what? That means $22. $22 is the benefit. So yes, this is the net benefit. This is the net benefit. So since shadow price, we can write that since shadow price is greater than the cost, therefore this offer should be accepted in terms of overtime requested, right? This is the first point. What is the second point? Second point is in terms of contracted hours, right? Now, what do you mean by this issue, this term contracted hours? See, it's simple. Contracted hours means that they want to have 1200 hours. They can give you 1200 hours. If we contract them for 1200 hours, that means whatever the production is, we have to pay them 1200 hours. I mean, they are asking $36 per hour now. So $36 per hour multiplied by 1200. That is the amount which we have to pay if we make a contract with them that we want you to work 1200 extra hours. Because once we are committed, we have to pay them. So what this question is saying, this question is actually asking you about whether you are ready, whether you can utilize these 1200 hours or not. Because see, after labor, material is also a limiting factor, and the distance between material and labor is not very high. There's a very narrow distance between labor and material, right? There's a very narrow distance between labor and material, just this one. So if you relax your labor requirement, then there are chances that somehow you will have more labor hours, but not enough material. So they are just trying to identify that how many hours will be enough for you to produce the more production, right? Now, you can do it in 2 ways. I personally believe maths is a better idea, right? So see, we are doing it's second point, right? The quantity of hours. See, we have 5400. If we have 5400 available material, and we will utilize 4860 kilograms of material in case we are manufacturing 6000 of X and 12,000 of Y. So how many kilograms we are left with? 5400 minus 4860, 540. We will be left with 540 kilograms. This is the first point. This is the second point which we are discussing. We will be left with only 540 kilograms. We are left with 540 kilograms, right? And 540 kilograms is available. How many units you can manufacture from this 540 kilograms? See, why demand of Y is already fulfilled. We manufacture 12,000 units of Y, so we are done with that part. The extra labor hours which will be available for us, we will utilize those hours for the manufacturing of product X, right? Y is done. Y is okay, fine. Y demand of Y has been fulfilled. Whatever hours will be available, we will use it in the manufacturing of X, right? So how many units you can manufacture by using these 540 kilograms? See, how many kilograms of X required for 1 unit? How many kilograms of X of material is required for 1 unit of X? 0.27 kilograms are required for 1 unit of X, right? Now, if you have 540 kilograms, how many units maximum you can manufacture? We can manufacture 540 divided by 0.27 divided by 0.27, 2000 units. We can manufacture 2000 units of X by using remaining material or excessive material. Now, how many hours will be required for 2000? Labor hours required for 2000 units of X will be what? 2000 times 0.5 of X. Right? So that means if you contract for 1200 hours, then till 1000 hours you can utilize. You can utilize our labor hours till 1000 hours. But remaining 200 hours will not be utilized because in that case, material will not be available. So what we can advise the company, the labor hours for which they should contract should be 1000. They should not contract for more than 1000 hours. So rate of pay is okay, fine for us, but labor hours need to be reconsidered because 1200 hours are too much. Maximum you can go for 1000 hours, right? What is the third point? What can other point we can consider? That's up to you. I mean, you can write that if they work overtime, there will be inefficiency. If they are working overtime, then there can be wastage. Wastage of material or any other factor which you consider. So that is not connected with this question. That is completely up to you, right? So we can write that inefficiency part, that there are less chances that labor will manufacture the product in exactly 0.5 hours, considering the fact that they are working overtime, right? So that's the end of this video. I hope you got all these things, and I hope you understood this question. That's now for today. Have a nice day. Allah Hafiz.